This video is on Unit 6, Chapter 13, Natural Logarithms, Lesson number 1, Solving Natural Log Equations. So in this lesson, and in this chapter, we are going to be talking about what are called natural logs. So these are logs, but these logs have a base of e. So what is e? E is an irrational number with an approximate value of 2.71828. Let me show you. E can be found by hitting second divide. So there's E, and the calculator stores a little bit more than just 71828. 718281828. Not sure what those next few numbers are. You would almost think that it's repeating, but it does not repeat. This is an irrational number. So remember that with irrational numbers, they do not have a repeating pattern and they never end. E often occurs as the base of exponential and logarithmic functions that describe real-world scenarios. All of the rules and properties and methods that we learned in the last chapter are also going to apply to these natural logs. Base E exponential functions. So exponential functions with a base E are called natural base exponential functions. So an example here is f of x is equal to e to the x, where the base on the exponent is an e. That's the natural base exponential function. We also have base e log functions. Logarithmic functions with base e are called natural logarithms. Example, f of x is equal to log base e of x. Now, we don't ever see it written that way. When it says this is often abbreviated as, it is almost always abbreviated as f of x is equal to, that's an L and an N representing the natural log of x. So when we see an L and an N together, that means that we have log base e. So let's look at converting between forms. In this first set, it says write each equation in log form. So e to the x is equal to 24 would be log base e of 24 is equal to x. Now again, we don't write log base e. We typically just write ln for natural log of 24 equals x. Same thing on number 2. That would be log base e of x equals 9, or natural log of x equals 9. And number 3, e to the x plus 5 is equal to 72 would be log base e of 72 is equal to x plus 5, or again, just natural log of 72 is equal to x plus 5. The next section is going to ask you to change from natural log to exponential. So when we look at number 4 and we see the ln, that means that the base is e. The base is e. So e to the 58th power is equal to x. Same thing on number 5. E to the x equals 6. And number 6, e to the 32nd power is equal to x minus 9. So this is just like we did in chapter 12, lesson number 1. We're converting between exponential to logarithmic and logarithmic to exponential. In this next section, we are going to be condensing, just like we did in chapter 12. This is condense each expression into a single logarithm. Number 7 says the natural log of 3 plus the natural log of 16. So because there's a plus in there, you're going to multiply the 3 times the 16, and it's going to say natural log of 48. And then on number 8, the first thing that we need to do is move the 2. So the natural log of 63 minus the natural log of 9. And then because there's a minus, we're going to divide 63 divided by 9 is equal to 7. So this will say natural log of 7. And last one on this line is number 9. Again, move the 1/3 and move the 2. So the 1/3 is going to indicate the cube root of 64. And the cube root of 64 is 4. So now this is natural log of 4 plus the natural log of x squared. And because there's a plus, when I condense, I'm going to multiply 4 times x squared is just 4x squared. On the last set, it says it's asking us to expand. This is the section that we skipped, so I'm going to continue to just skip that and move on to the next section of your notes is solving these equations. So just like with logarithmic equations, the methods that we're going to use are the same. So if it's log equals log, you're going to drop the log and solve. If it's log equals a number, you're going to convert to exponential. So let's concentrate on those two. Number 13, I've got a log on both sides, and it's natural log, but it's still a log. I'm going to drop the logs and solve. So we have 4x minus 27 is equal to 15 minus 2x. I'm going to add the 2x. 6x minus 27 equals 15. Add the 27. And we get 6x equals 42. And divide by 6, and we get x equals 7. And again, you would need to check your answers here, making sure that when you plug in the 7, we do not get a 0 or a negative number in those parentheses, and you won't. X does equal 7. Let's look at number, let's jump down to number 16. Actually, 15. Let's look at 15. Number 15 has a log on both sides, and it has too many logs on both sides. So we're going to condense the left, condense the right before we drop the logs. So on the left, we need to take 72 and divide by 4. So 72 divided by 4 is 18. So this is going to condense to the natural log of 18 equals, on the right side, there's a plus between, so we need to multiply 6 times a minus 2 is going to give me the natural log of 6a minus 12. And now we can drop the logs and solve. 18 equals 6a minus 12. Add the 12. 30 is equal to 6a. Divide by 6. A equals 5. And then plug that in. For time's sake, I will let you know that it does work. Let's check out number 16. Number 16 says 2 times the natural log of m plus 4 is equal to the natural log of 4. So here again, same thing. We've got logs on both sides, but the left side needs to be condensed. So this is going to say the natural log of m plus 4 squared is equal to the natural log of 4, because the 2 becomes the exponent. Now I can drop the logs, and we have m plus 4 squared is equal to 4. Now remember that with m plus 4 squared, you have m plus 4 times m plus 4. So going through your distributive property, m squared plus 4m plus another 4m plus 16 is going to give me m squared plus 8m plus 16 is equal to 4. This is a quadratic and has all the parts, so I'm going to subtract the 4 first. And then I'm going to use my graphing calculator to solve this. So just like we did with logarithmic equations, you can either solve by graphing, solve by using quadratic formula or polysymult. So I'm going to use graphing. I've got y equals x squared plus 8x plus 12, and negative 2 and negative 6 are the two numbers where the parabola hits the x-axis. But if we go back to the original equation, we look back at the original. If you plug in a negative 2 inside the parentheses, negative 2 plus 4 is 2, that's positive, that's good. But what if we plug in negative 6? What is negative 6 plus 4? Well, that's a negative 2. We cannot take the log or the natural log of a negative number. So negative 6 ends up being extraneous, and m is equal to negative 2 is the only answer there. All right, now let's look at numbers 17 and 18. 17 and 18 have a log on one side. So this is your log equals a number. Log equals a number. So the thing here is to convert to exponential. And anytime you see natural log, you've got to think that the base is an e. So this is going to be rewritten as e squared equals 8x. Now the reason why a few minutes ago I showed you where the e is because e squared becomes a number. So let's go to second divide and then square. 7.389 is equal to 8x. So then we want to divide by the 8, and x equals 0.924. Again, you're going to want to substitute that back in because logarithms are utilized here. Let me show you where the natural log is. So if you find log, right underneath log is natural log. And we're going to do 8 times that 0.924. And this should equal 2. Close enough. So that's my answer on that one. Same thing on number 18. There's a log on just the one side, so we need to change this to exponential. However, on number 18, before we change it to exponential, we first need to condense the left side. So natural log of x minus natural log of 9 is going to condense to natural log of x divided by 9, and that's going to equal to 7. So again, converting this to exponential is going to be e to the 7th equals x over 9. So we're going to do e to the 7th, second divide, raised to the 7th power is 1096.633. So I'm going to bring this over here. 1096.633 is equal to x over 9. We need to multiply by 9 on both sides. So take that answer times 9, and we get 9,869.698 for x. And I can tell you, just to save some time here, that will work. Well, actually, let me just explain. The natural log of x, 9,869.698, is positive. It is not 0, so you're good. Now we get down to numbers 19, 20, 21, and 22. These equations are in exponential form. So just like before, with exponential equations, there were two different things. There were same base and not the same base. Now, with natural logs, we cannot make the left side and the right side have the same base. So the only method that we need to know for these exponential is to change it to log and I should say natural log. Let me rewrite that. To natural log and solve. Now, you may have to do some condensing. The whole getting the exponential part by itself is still a thing, so be careful. Number 19, we have e to the x is equal to 57. So we can go ahead and write that as the natural log of 57 is equal to x. The natural log of 57 is going to be 4.043. For x. And again, you can substitute that back in to check. E to the 4.043. Second divide, raise 2, 4.043. Should give me 57 or something very close to, and it does. Number 20, the first thing that we need to do on this is get the exponential part by itself. So I'm going to add 6 e to the y plus 3 equals 30. Now change it to logarithmic or natural log. Natural log of 30 is equal to y plus 3. So we're going to find the natural log of 30. And that's going to be 3.401 is equal to y plus 3. And then we need to subtract the 3 minus 3, and we get 4.401. Again, if you substitute that back in, it should work. 21 says 5 times e to the 4n is equal to 95. Again, you need to get this e to the 4n by itself. The 5 has got to go. So because that's times, we're going to do the opposite and divide. Now we have e to the 4n equals 95 divided by 5 is 19. Now change it to log. Natural log of 19 is equal to 4n. So let's find the natural log of 19. 2.944. And divide by the 4. 0.736. 0.736 for n. Again, if you substitute that in, I will tell you just for time's sake that it does work. Last one, number 22. Again, I repeat, get the exponential part by itself. And it does matter which one you do first. Start away from it. So I'm going to minus the 3. 87 minus 3 would be 84. And then I'm going to divide by the 2. And I get 42. And then we're going to rewrite it in log form. Natural log of 42 equals c minus 9. So natural log of 42, and then you're going to end up adding 9. Natural log of 42. And then we need to add the 9. And I'm jumping all the way to the answer here, 12.738. I kind of skipped the whole 2-step there, but I'm trying to save some time here. Hopefully you understood that. Those are your notes for Chapter 13, Lesson 1.